I hope all of you can see the screen. Is it? I hope all of you can see the screen. Okay, okay. Okay, so in the last class we were discussing about the moment of resistance. So the procedure of finding out moment of resistance is exactly same with the working stress method, but the formula is different here. Okay, and all of you don't. I told you in the last class also. No need to remember the formula because the formula is already given in IS 456. Okay, but you have to know. But you have to know which clause you have to use and which formula you have to use. Okay, so again you can you go to IS 456, open the PDF, and go to clause number G.1.1. Annexure G, clause number G.1.1. Page number, I think it will be page number 96. Page number 96. I hope all of you have find it. I hope all of you have got the page. This is the clause. Annexure G, clause number 38. This is the clause G.1.1. I hope all of you have got this. Yes? I think all of you have got this page. Okay, so so now see the PDF now. Okay, so the procedure is for finding out moment of resistance, just like the working stress method, either you can do total compressive force into lever arm or total tensile force into lever arm. Okay, so compressive force is this value, it is written in 456 also. So this into this lever arm, C into A or T into A. Okay, so moment of resistance will be total compressive force into lever arm or total tensile force into lever arm. Okay, so you can see here, lever arm means the distance between total compressive force and total tensile force. Okay, so from this you can see here, D is the distance between the topmost layer to the center of the reinforcement. That is our effective depth. And our total compressive force will be at a distance of 0.4 times of XU, depth of neutral axis. So the lever arm will be D minus this distance. So it will be D minus 0.42 XU, this height. This is our lever arm. Okay. So moment of resistance will be C into lever arm or T into lever arm. Okay, you can see here moment of resistance equal to C into lever arm equal to T into lever arm. Okay, so if you consider this compressive force, then the equation becomes 0.36 FCK B into XU into D minus 0.42 XU. Okay? This will be the equation. This will be the equation. So from this equation, if you simplify again this equation, that means if you take this D common from inside, then finally you will get this equation. Okay. Finally you will get this equation. 0.36 FCK XU by D. This equation you will get. Okay. Similarly, if you use this equation, means total tension into your lever arm, then the formula will be T into this distance. So T is 0.87 Fy AST into D minus 0.42 XL. This one. Okay. So similarly, if you can simplify this. Okay, derivation is not at all required, only the formula is required. Okay, so moment of resistance equal to this formula. Okay, so you can see this formula is also given in your IS 456. M equal to 0.87 Fy AST into D 1 minus this portion. This formula is nothing but this one. Okay, I hope all of you can see this. In IS 456, this formula is directly given. Moment of resistance equal to 0.87 Fy into area of steel in tension into effective depth within whole bracket 1 minus this value. Okay, so how we have got this? I have just shown you how we can derive this equation. Okay, just now I have shown you how to derive this equation. Okay, derivation is not at all required. Only I have shown you how to get this equation. Okay, this is a very simple equation. Only we have to modify. Okay, so now let us go to the PDF again. Okay, so next again, this is next again limiting value of moment of resistance. That means maximum value of moment of resistance. Okay, so if you whenever you write limiting value, so always you remember whenever you are writing limiting value, that means in that case your XU will become XU max. Okay, you can see here. You can see here. So whenever you will write limiting value, then you have to understand we have to take the maximum value of depth of neutral axis. Okay, so limiting value of moment of resistance, if you use this formula, then you will get 0.36 FCK. In place of XU, you have to write down XU max. Similarly, here also you have to write down XU max. Okay, so if you put the values here, you will get the equation. You can see here the limiting or maximum value of moment of resistance will which we will get by substituting XU max for XU in equation number 2. Okay, and this equation is also given in IS 456. So no need to remember again this one. All of you, no need to remember this, because this formula is also given in IS 456. Just see this equation. IS 456, all of you see this equation again. This is the equation. Limiting value of moment of resistance, see this equation. No need to remember the equation because it is already given. This is the limiting value of moment of resistance. Mu lim, okay, XU max by D. This equation is already given. So no need to remember this. No need to remember this. Only you have to know for getting this formula in which clause you have to use. Okay. So this is the most important clause in this semester. This clause number 38.1 and this annexure G. Okay. This annexure G and clause number 38.1 is the most important part in your entire syllabus. Okay. So this is the value of limiting. This is the limiting moment of resistance. Okay, limiting moment of resistance. Okay. So now, in the last class, I have shown you different values of XU max by D for different grades of steel, is it? If you go to clause number 38.1, okay, so now see, we have got the equation for limiting value of moment of resistance, is it? This equation, this is the equation for a limiting value of moment of resistance. Okay, so now if you are given in example, say example, you are using mild steel and you have to find out the limiting value of moment of resistance. So what we have to do, if you use directly this equation, what we will do, you will find out, you have to find out XU max, you have to find out D, then you have to put the value of FCK. Okay, then only you will get the value of limiting moment of resistance. But there is a simple way to find out limiting moment of resistance by putting the value of XU max by D directly from I square. Okay, so last class I have shown you. Okay, so all of you again go to clause number 38.1, page number I think 70. All of you go to page number 70 again. All of you go to this page number. Have you got this again? This page? Okay, so I think you remember last class also I told you how to use these values. Is it? Last class also I told you how to use this table. Okay, so now we are going to use these values now, because we know that the limiting moment of resistance formula is this one, 0.36 FCK XU max by D. This one, this is the formula for limiting moment of resistance. But if the grade of steel is given in your question, we can directly put the values of XU max by D from IS 456. Okay, so if you are using mild steel, you can directly put the value of XU max by D equal to 0.53. Similarly, if Fe415 is given, you can put the value of XU max by D equal to 0.48, and similarly for 500 you can put 0.46. Okay, so now you see here in the PDF, see, if you are using mild steel, and you need to find out limiting moment of resistance, so the value of XU max by D equal to 0.53 according to IS 456, this value. Okay, this value 0.53. So if you put the value here in this equation, in place of XU max by D, if you put 0.53, this value, and if you simplify it, then what value you will get? You can see this equation becomes a very simple equation. For mild steel, limiting moment of resistance equation, you can see here, this equation is very simple now. This is the equation now. Only this, 0.148 FCK BD square. Is it simple now? Okay, so now you see this equation. This one is this equation and this equation. Which one is simple? This one or this one? I hope this equation is very simple. I think this equation is very simple. Okay? We can see this equation becomes a very simple equation. For mild steel, limiting moment of resistance equation becomes very simple. It is 0.148 FCK BD square, and it is very easy to remember this. Instead of using this clause and going to use this equation for any grade of steel, if the grade of steel is given, and if you can remember this value, then it will be very easy to find out, or you can say you will within a very short time you can find out directly limiting value of moment of resistance. Okay, so now similarly for Fe415 also you can find out the value, and Fe500 also you can find out the value, and here in this table these values are already given. You can try this, how you have got this value, how you have got this value. You can try this by yourself. Okay, see, you know, for mild steel, just now I have shown you how to get this equation 0.148 FCK BD square. Just you need to put the value of XU max by D from IS456. Okay. If you are using FE250, put the value 0.53. For 415, 0.48, and for FE500, put the value 0.46, and you just simplify it. Multiply the value and simplify it. You will get this equation. For FE250, you will get this value. For FE415, you will get this equation, and for FE500, you will get this equation. Okay. So these are the equations of moment of limiting value of moment of resistance for different grades of steel. Okay, these are the basic equations. So now, if you are using mild steel and if the grade of concrete is given M20, so the limiting value of moment of resistance will be this one. Directly you can find out. Similarly, if you are using Fe415 and if you are using M20 grade of steel, M20 grade of concrete, then the limiting value of moment of resistance will be 2.76 BD square. And you can see this equation is very simple now. Instead of going to this equation, if you can use this equation, it will be very, very easy for you. Okay. Similarly, if you are using Fe500 and if you are using M30 grade of concrete, so limiting moment of resistance will be 3.99, or you can say 4 BD square. So you can see this equation has become a very simple equation. Okay. All of you no need to remember these values. Only try to remember these three equations. Limiting moment of resistance for mild steel is 0.148 FCK BD square. For Fe415, MU lim, that means limiting value of moment of resistance is 0.138, and for Fe500 this will be 0.133. Okay. So if you are finding it very difficult, I will give you one simple trick how to remember this. Just remember this value 0.148. 0.148 for Fe250, 0.138 for Fe415, and 0.133 for Fe500. Because the remaining portions are given in as you can see here, the remaining portion is given in this equation. Because at every point of time you will have this IS456 with you. So this FCK BD square will be there with you. Okay. But what is the value of this other portion? For mild steel it is 0.148. For Fe415 it is 0.138. And for Fe500 this value is 0.133. And the remaining portion is given. FCK BD square will be there. But this one 0.36, so all of you, I will suggest that you try to remember these three equations. For Fe250, limiting value of moment of resistance is 0.148 FCK BD square. For Fe415, this is the equation, and for Fe500, this is the equation. It is very simple. And if you remember these three values or these three equations, then you will find it very, very easy to find out the limiting value of moment of resistance. Within 1 minute, you can find out. If the grade of steel is given and if the grade of concrete is given, okay, you can directly find out what is the limiting value of moment of resistance within 1 minute. Okay, so I suggest you try to remember these equations, and if you can't remember this equation, then every time you have to use this equation. every time you have to use this long equation, okay, which is given in IS 456. But for your exam purpose, it is better to remember these three simple equations. Okay, if you want to save your time during the exam, I am suggesting you to please try to remember these three equations. Otherwise, for every problem, you have to use this long equation. Okay. Okay. So next part is percentage of steel. So similarly, for getting the percentage of steel again, the basic equation is total tensile force equal to total compressive force. Okay. So total tensile force is this much. Total compressive force is this much. And from here you can find out AST by BD, that means percentage of steel we can find out by this value. AST by BD equal to, this is the equation for percentage of steel. Okay. If you simplify this equation, you will get this final equation. Okay. This is the equation for percentage of steel. Okay. Then again, if you want to find out the limiting value of percentage of steel, that means maximum value of percentage of steel, then again in place of XU you have to put XU max. I told you before also, whenever you will see limiting value is mentioned, then you have to use the maximum value of depth of neutral axis. That means in place of XU you have to write down XU max. So here in this equation you just put XU max, then this will be the equation. And again for this equation also you can put the value for this fraction. For Fe 250 you can put the value 0.53. For Fe 415 you can put 0.48, and for Fe 500 you can put 0.46 from this table. Okay, from this table you can put the values. Okay, so no need to remember this. No need to remember this formula. Only you try to remember this one. This formula. Percentage of steel. Okay, percentage of steel formula is this one. Okay, percentage of steel formula is this one. Okay, so next our aim is to find out, similar to the working stress method, here also in every problem, before finding out moment of resistance, first we have to determine what is the type of section, whether it is balance section or over reinforced section or under reinforced section. First we have to determine that, and then only you can find out moment of resistance. Okay. Okay, so now in this case, for getting the balance under reinforced and over reinforced section, we have to find out XU, that means depth of neutral axis, and XU max. Okay, and then we have to compare these two values. Okay. So XU you will get from this equation, from clause number G.1.1 from IS 456. Okay, and XU max I have shown you this formula in the last class. Okay. So from these two formulas, you have to find out first XU, that means depth of neutral axis, and XU max, that means limiting value of neutral axis. Then after getting these two values, we have to compare. If these two values are equal, then it will be your balance section. See here, for balance section, XU equal to XU max. Okay, can you tell me what will be the condition for under reinforced section? Which value will be more for under reinforced section? XU or XU max? Raju? Arif Khan, which value will be more for under info section? XUmax. Okay. Okay, Raju, XUmax. Okay. Yes. Okay. Yes. See, for under info section, as you know that our steel will fail first. Okay. Our steel will fail first. So your depth of actual neutral axis will be shifted upwards. That means your actual neutral axis depth will be less than XUmax. Okay. For under info section, XU will be less than XUmax. And for over info section, XU will be more than XUmax. Okay. See here. For under info section, XU is less than XUmax. And for over info section, XU is greater than XUmax. Okay. Okay. Say you are given a balance section. Okay. Say you are given a balance section. So in that case, for finding out moment of resistance, which formula we have to use? Because we have two formulas for finding out moment of resistance. I will show you the formulas. See, we have two formulas. This is one equation. This is another equation for moment of resistance. Say you are given a balance section. So which equation we are going to use? This equation or this equation? Hmm? Which equation we are going to use? Which equation we have to use for a balance section? We have equation 2 and say this is equation 3. Okay. That means we have two equations for moment of resistance. And you are given in a question, you are given a balance section. So which equation we will use? Either equation 2 or equation 3? Equation 3. Okay. Anyone have any other answer? Okay. Okay, Fibataba. Okay, so any other answer? Raju? Arif Khan? Rupasri? At least some of the students, please answer. Only two, I have got only two answers. From 53 students, I have got only two.
सर बैलेंस सेक्शन के लिए सर किसी को भी यूज कर सकते हैं सर.
Okay. Yes. Yes, I told you before also. I told you before also that for balance section, you can use any equation, either this or this. It is not that you have to use equation 2 or you have to use equation 3. You can use both the equations. Fiva Tava, you are correct. Hania, you are correct. Okay. For always remember, for balance section, you can use any equation because in a balance section, both steel and concrete will fail together. At the same time, both will fail. Okay, so we can use both the equations. Okay, you can use either equation number 2 or you can use either equation number 3 also. Next, for underreinforced section, now you tell me, for underreinforced section, which equation you have to use? Equation 2 or equation 3, or you can use both the equations? I am asking you for underreinforced section, which equation you have to use? equation number 2 or equation number 3, or we can use both the equations. Equation number 2.
3 यूज कर सकते हैं
Under info section, equation number 2.
सर 2 और 3 से किसी को भी यूज कर सकते हैं सर
अंडर इन्फोर्स के लिए लिखा है ना
हेलो सर
अंडर इन्फो सेक्शन के लिए 2 और 3 कोई भी यूज कर सकता है
यस सर बिकॉज वो में AST है ना सर
कौन सा यूज करना होगा बोलो
सर 3 ही होगा
ओके ओके यस यस अंडर इन्फो सेक्शन मतलब क्या है अंडर इन्फोर्स मींस आवर स्टील विल फेल फर्स्ट okay so those who are saying equation number 3 all are correct we can't use equation number 2 okay because under info section में क्या होगा first our steel will fail that means the strength of the beam or the structure will be determined by the steel okay so we have to use the equation of this where the tensile force is there okay so equation number 3 we have to use so those who are saying equation number 3 all are correct Raju you are saying first you have said 2 then you are saying 3 huh okay so for under info section always remember जहाँ पे steel का AST यूज है वही यूज करना होगा simple if you want to remember simply so for under info section you have to see where AST is there you have to use that equation for simplicity I'm just telling you जहाँ पे AST दिखाई देगा वही equation use कर दो yeah so for over info section we have only one equation now we have to use this equation but do you have any other difference here means for under info section directly we will use equation number 3 but for over info section can you tell me is there any modification in this formula or directly we will use equation number 2 for over info section if you have to find out moment of resistance we know that we have to use equation number 2 but in the equation my question is in equation number 2 do we need to modify this equation or directly we can use this equation directly use equation number 2 modify it yes modify it okay modify क्या करना होगा फिबा तबा good you are correct roll number 84 enrollment number 84 you are correct but what you have to modify okay yes good one chin lamu good very good we have to modify it and we have to put the limiting value of xu max that means in place of xu you have to write down xu max okay you have to put xu max and if you put xu max then it will become your limiting moment of resistance limiting value you have to put okay okay so now I am showing you the equations for balance section we can use any equation this one or this one for under enforced only this equation is also given in IS 456 clause number you can go to clause number G.1.1 you will get this equation for over info section you can see this equation it will become mu lim and in place of xu you have to write down xu max okay so now we have seen all the formulas all the procedures now we are going to solve some numericals okay so all of you please take your pen paper calculator with you because now we are going to solve some numericals. Okay, all of you take your pen, paper, IS 456 and calculator with you. Okay, so let us go to the first problem. Okay, so see this problem. I hope all of you can see it. Is it? So first problem is very simple one. We have to determine the depth of neutral axis. Okay, all of you read the question. The depth of neutral axis of a beam 250 into 400 millimeter. Reinforced with this one. Also check the type of section. Use M20 and Fe 415 steel. Okay, so since M20 grade of concrete is given, so FCK will be 20. For Fe 415, Fy will be 415. B is given, D is given, area of steel is also given. 3 bars of 20 mm diameter. So 3 into pi by 4 D square. So that will be your AST. Okay, so now how to find out the depth of neutral axis? Okay, so for using this equation, what you have to do, you have to write down the clause number. Okay, you have to write down the clause number. Every time whenever you are using this equation, every time you have to write down the clause number. As per clause G.1.1. Okay, so every time whenever you are writing down the equation, wait. Whenever you are using this equation, every time you have to write down this clause number G.1.1. As per clause G.1.1, G.1.1, XU by D equal to this equation. Okay, every time. In every problem, whenever you are writing this equation, in every case, you have to write down the clause number. Okay, so in this equation, I think you can see all the values are given. Fy is given, AST is given, FCK is known, B is known, D is known, everything is known. Okay, so XU you will get 189 mm. That means depth of neutral axis is this one. Depth 189. Okay, so now you have to find out XU max. So how to find out XU max? Because again you are given Fe 415 steel. So for this steel, according to clause number 38.1, as per clause 38.1, for Fe 415, XU max by D equal to 0.48. Okay. Again here also you have to refer the clause, because this equation this value you are getting from IS 456 and the clause number is 38.1. This is the value which you are trying to use, which you are using now. Okay, so you have to refer the clause because this value is coming from this clause number 38, I think. Clause number 38.1. You have to refer the clause from clause 38.1 for FE 415 XUmax by D equal to 0.48. Okay. Therefore, XUmax you can find out 0.48 into D is given. So you have got 192. Now you compare the two values. XU is less than XUmax. Therefore, our section is under enforced. That is the final answer. Type of section will be it is under enforced. Okay. So we have seen that we have determined the depth of neutral axis and also we have determined the type of section. Okay. I hope all of you have understood this problem. It is the simplest one. If you have any doubt in this question, you can ask me. Okay, our class will end very soon. You join the class again by the same link. Okay. You join the class again by the same link. As soon as this class ends, you join the class again by the same link. Okay, so do you have any doubt in this problem? Anyone have any doubt in this problem? Time means just after the class you join again because I have two classes today, no? At the end of now the class will end very soon. I think within 1 minute this class will end. So as soon as this class is over, you just use the same link to join again. Do you have any doubt in this problem? Anyone have any doubt in this problem? No, sir. Okay. So let us see the next problem. Well, so let us see the next problem. Examples of moment of resistance of singly reinforced beam.